All right, everybody, welcome to lesson 20 of Conquering Algebra 2. In this lesson, we have two concepts. We're going to talk about simplification of radicals, which we know as roots, and then also finding the line, the equation of the line when there is a parallel line given and a point. So first off, simplification of radicals, we have to remember that when we have a root times a root, it's going to equal the two numbers, two letters, whatever, the two values inside. But that also means the opposite. When we are given a number, we can also break it down into two roots of its own, and sometimes one of these roots can be simplified. An example of this would be the square root of 50. Because within the square root of 50, I have 2, and I also have 25. And whenever I do that, I can remember 25 is a perfect square. The square root of 25 is 5, so I can rewrite this answer to be 5 square root 2, and this is our simplified radical. Whenever we have square root 50, it's not reduced to its lowest term. Much like a fraction, if we were to have 4 over 8, that's not simplified. You always have to simplify your radicals. And so what you have to do is you have to find any perfect squares, square root them, get them out of there, and just write what is left. So let's do some practice. Okay, so in our first example, we have 3 square root 50 minus 5 square root 200. Before I do anything, looking at it right now, I can't do anything with it. I can't add my like terms because my roots are different. So I need to try to simplify my roots and see, once I do that, is there a like term, and then add it. So first step we had is simplifying the radicals. 3 is not going to change, but we also know that within 50 we have 25 and 2 minus 5, and then we have 100 and 2, because 100 is a perfect square as well as 25. So now I'm going to solve my perfect squares. So 3 times 5 root 2 minus 5 times 10 root 2, and now I'm going to multiply these numbers. So 15 root 2 minus 50 root 2. So now that I've simplified my radicals, I can add like terms. I'm not going to mess with the square roots of 2. What we need to do is we need to look at this as if instead of a radical, we had a variable. What if this problem was 15x minus 50x? I would only work with the coefficients in front. I would only do 15 minus 50. Same thing with our radicals. This answer is going to be 35 root 2. Our square root does not change. So that's it. We just want to double check and make sure that our root is simplified to its lowest term, that there are no perfect squares trapped inside there, and we're good to go. So let's do another practice. In our next example, all 3 of these roots are being multiplied. So there's 2 steps to get the multiplication part done. The first step is we're going to multiply our numbers outside the root to each other. So 3 times 4 is 12, times 2 is 24. The second part is we're going to multiply inside the radicals. So 2 times 12 is 24, times 3 is 72. Okay, so we have just done steps 1 and 2. We've multiplied outside the radicals. Now we've multiplied inside the radical. Now we need to simplify the radical if we can. I happen to know off the top of my head that 72 is 36 times the square root of 2, or square root 36 times square root of 2, and this is a perfect square. So this becomes 24 times 6 square root 2, and then 24 times 6, I'm going to do that in my calculator. And it's going to be 144 square root 2. So that last step of simplifying was this part of multiplying right here. So we're done. Our last example for this concept is the same thing. We're still going to be multiplying radicals and simplifying them, but in this case they're going to want us to distribute. So in step 1 of distributing, we're still going to do what we did in the last example. We're going to multiply our outside times our outside, and then our inside times our inside. We're just going to do it to both of these terms. So in this first one, we have 2 times 4, so 8 square root, and then 3 times 3 is 9, minus Okay, so there is no number right here, so we understand it to be 1. 4 times 1 is 4 square root, and then 3 times 6 is 18. Step 2, we're going to simplify our radicals. Looking at this, I already know this is a perfect square. This is going to be 8 times 3 minus 4, and then within here, I know I have square root 9 times square root 2, because 9 times 2 is going to equal 18, and this is a perfect square, so this becomes times 3. So 8 times 3 is 24 minus 12 square root 2. So we simplified our terms. Step 4, add like terms if possible. And I have a normal number and I have a radical. So I don't have like terms. This is as far as we can go. This is simplified. And we will have quite a few problems where we don't get to do step 4. There are no like terms, but you still have to check just in case. So this is it. We have finished the problem. The second part of this lesson is us finding the equation of a line when they tell us it is parallel to a different line, and then they also give us a point within that line. So before I do that, I want to cover something very important. What makes two lines parallel? So we're going to graph these 3 lines, and I want you to see what they all have in common. Okay, so after looking at that, we saw that they all had the same rate of change. And looking at these 3 equations, there is one number, one term, whatever you want to call it, that they all have in common. And it's not y and it's not x, that's every line, period. What makes these 3 lines have similarities is their slope, their n. So whatever this number is that's being multiplied to x, when it is in slope-intercept form, that is going to be something that we are going to reuse. So now that we know that, let's look at an actual practice problem and see how we would solve this. Okay, so in our practice problem, it says, find the equation of the line that is parallel to 2y minus x equals 2 and passes through the point 3, negative 1. So first thing that we have to know is, I'm going to use this information. It is parallel to this line. Now, the problem with that is I can't just look at this equation and know instantly what my slope is. I have to get this equation into slope-intercept form, so I need to get y by itself. So that's step 1. Get this one where I can find the slope instantly. So we have 2y minus x equals 2. I'm going to move the x over here. So that's gone. And we have 2y equals x plus 2. We're going to divide by 2. And I got to divide each part by 2. So y equals 1/2 x plus 1. Okay, so now we've done it. We found our slope. M equals 1/2. So I'm going to use this information plus my formula, y equals mx plus b. And I'm going to plug in these points to find my y-intercept. Because remember, when we're finding the equation of the line, there's 2 pieces of information we need. We need the slope and we need the y-intercept. We found part 1, we need to find part 2, and we're going to use this given point to help us find that. Okay, so we're working with y equals mx plus b. I am going to replace these 3 with my y, my x, and my m. So we have negative 1 equals 1/2 times 3 plus b. Now we're going to solve for b and we'll have our y-intercept. So negative 1 equals 3 over 2 plus b. We're going to have to subtract 3 over 2 to get it gone. And b is going to equal, okay, so I'm going to change this to be 2 over 2. That's messy. So you know it's 2 over 2. So this will end up being negative 5 over 2. That is my y-intercept. So now that we have these 2 pieces of information, we can write the equation of our line. Remember, when they are asking these types of questions, they're wanting an equation. So if I do not have y equals, it is not an equation. Definition of an equation, it has to have an equal sign. So remember that. Don't just write this part. That is not the full answer. So we have y equals 1/2 x minus 5/2. Okay, so we have just found the equation of the line that is parallel to this line and passes through this point. So we've done it, we're good to go. All right, and that's it for lesson 20, reducing radicals, simplifying them, and then finding the equation of a line parallel to a different line with a given slope or with a given point. I hope this helped you guys out a lot and that it helps clear up some things that you weren't quite sure about. Make sure that you guys are practicing your homework at home so that way when we get to class, our question time can be more efficient because you know exactly what you need help with. I'll see you guys in class.